So you're telling me that
Yep.
you're going to take the battery out of this,
Yep.
and you're just going to use your energy harvesting chip so that this remains permanently on
Yep.
and won't ever have to have any other power source.
Yep. Exactly.
Hello, we are at CES yet again, and here we are at the mysterious world of energy harvesting. Yes, I don't know what that means either, but luckily we have Pierre from EPs who's going to explain to us how they do energy harvesting and their new chip that they've just launched at CES. So over to you, Pierre.
Yeah. Hi, I'm Pierre Louis. I'm a field application engineer at EPs, and I'm going to present you the new different PMIC that we develop at EPs. The first one is the IM3920. It's a PMIC with two independent inputs to extract the maximum power from two different sources. That can be two PV cells, that can be a PV cell and a thermoelectric generator, for example. So we will charge a storage element.
Forgive me.
Yep.
I'm a silly Englishman. Your accent there meant that I didn't quite understand the second part of what you just said. So you talked about the PV cell, and what was the other one that you talked about? What was the other energy source?
Thermoelectric generator.
Thermoelectric generator. Yeah. Excellent. Okay. Good.
So we will charge the storage element. It can be a lithium-ion capacitor or a lithium-ion battery. After, we have the possibility to supply the application thanks to a buck converter with a very good efficiency. And after, we have also a 5-volt CCCV charger that can be used like a USB charger. That's like a backup solution if the energy harvesting is not sufficient. You can use a USB charger to charge the storage element as a backup solution.
Yeah.
We have also an I2C communication that allows to have information about the environment, but also configure the PMIC. We can configure the source, the storage element protection, and so on. And thanks to the I2C communication, we can have some information like the power that we receive from the source and the power that we consume. So thanks to that, we can make the balance and know if we harvest or if we consume from the storage element. So that can be very useful for some applications from customer. After, the other PMIC that we launched this year is the 00920. It's a PMIC that is optimized for remote control market and for the keyboard. So there is some feature that is equivalent to this one. It's a boost converter with a single input. We will charge the storage element that can be a lithium-ion capacitor or a lithium-ion battery. We have the 5-volt CCCV charger that can be used as a backup solution. So if we take the example of a remote control like this one, we can replace the battery by an EVK of the IM00920, for example. So we can use this PMIC with a lithium-ion capacitor and replace the battery and have a fully autonomous device thanks to the energy harvesting. So we have also
So you're telling me that you're going to take the battery out of this, and you're just going to use your energy harvesting chip so that this remains permanently on, and won't ever have to have any other power source.
Exactly.
Right.
So thanks to the energy harvesting, here we have another example of the final product.
So just because that sounds to me like alien science. Okay. So let's just go back to the beginning.
Okay.
Let's just go.
Normally, the customer needs to replace the battery on the remote control.
So what I want to understand is, rather than talking about this individual chip, I'd like to understand if you know, I've been making these, and I've been putting a battery in it, forever.
Exactly.
And you come along and go, you don't have to do that anymore.
Exactly.
Okay, right. So explain to me how you explain to them how you do that. Don't necessarily talk about the chip. Don't tell me about the chip. Tell me about the process by which I take it you're harvesting the energy from the movement.
From the movement.
Yes.
Okay.
Yeah. So how does that work? Apart from an alien coming down, tell me what is the beginning of the process that you harvest energy to make sure that never needs a battery?
So this one, it's light-based energy harvesting.
Yeah.
So we need to have a PV cell, a photovoltaic cells.
Right, so that's where the energy comes from.
Yeah, exactly.
Right, okay.
So we just harvest the energy from the indoor light.
Yeah.
Thanks to our PMIC, we extract the energy from this PV cell. Thanks to an MPPT algorithm, so we extract the maximum power. And
So
we
where
charge-
is that energy source, for instance, on where would you put it on that device? It's in there.
Yeah, here it's a proof of concept and
Okay.
a retrofit that we made with a PV cell.
Yeah.
And there is just our PMIC where we connect the PV cell on it. There is
Yeah.
the storage element, is the lithium-ion capacitor, where we store the energy in case there is no light. For example, during the night,
Yes.
we need to keep the system alive just to
Exactly.
be able to use the remote control.
Yeah.
So we need to have the storage element. We need
Right.
the lithium-ion capacitor to keep the system alive during the night.
Yes.
And that's the reason why we need to have a small storage element, smaller than the battery that you have on your remote control,
Yeah. Yeah.
classic remote control.
Yeah.
And the customer will don't need to change the battery because it will charge
No. So
during the day.
so the reality is you're not actually selling an individual chip.
Yeah.
You're selling a system.
We sell the chip that allows the customer to implement the energy harvesting and maximize the transfer from the source to the storage element. And we help the customer to implement that in the device.
But when you're talking to a customer, there are elements of that energy harvesting that you don't play a part in. I understand that you have the chip,
Yeah.
but so how do you integrate with the power source and the energy storaging part, or do they have to look after that themselves?
So they need to make the things by themselves.
By themselves.
We provide an ecosystem of partners, so we can provide some
Right.
solution for the PV cell, solution for the storage element, for any kind of harvester.
Yeah.
By
Yeah.
the way.
Yeah.
And we help the customer to implement that and find the right solution. But we sell only the chip and
No,
let the customer.
okay, that's fine. I understand.
Yeah.
I understand. So this is a new chip, and it's totally dedicated to things just like that.
Yeah, remote control, keyboard, all the device that has a battery inside and the power consumption is quite low. You can implement energy harvesting thanks to our chip.
Okay, all right. So for our community,
Yeah,
I'm still of the view that it's alien technology, energy harvesting, right? So just give us the beginner's guide, because we haven't really done that at ipXchange. Give us the beginner's guide of how energy harvesting. Just if somebody comes to you,
Yep.
let's not necessarily
Yeah.
focus on that chip. Somebody comes to you with a proposition and says,
Yep.
"I don't want to have a battery in my system."
yeah.
How does that conversation start, and then where do you go with it? So
Yeah.
just a beginner's guide to how does energy harvesting work.
Yeah. So the first step is to know the power consumption of the device because it's quite important for the application. If the power consumption is too high, we will target an extension of lifetime more than a fully autonomous device. So we start by just make a power budget analysis and create a report that explains if it's possible to make a fully autonomous device and replace the battery.
Right.
When it's done,
So you do that analysis with the customer.
exactly.
Yeah.
So we ask the power consumption, make some calculation just to know what target we can achieve
Yeah.
thanks to the energy harvesting, replace the battery.
So let's just have a discussion about energy harvesting. I know we've talked about that, but let's talk. So where are the limits of energy harvesting today? Let's just not talk about EPs for the moment. Let's
Yep.
talk about just generally. We're at CES. We're absolutely surrounded by technology.
Yep.
Obviously, power, low power, AI, all those kind of things. Well, obviously, AI is not going to come into this discussion. But what are the limits of energy harvesting today in terms of end-use devices? Where do you go? Right, we can't play there, but we can play there.
Yeah, so if the power consumption is too high, due to the fact that, for example, there is a cellular communication that's just make a communication every time, it will be hard to implement energy harvesting because the power consumption will be too high.
Yeah.
So that's why we need to just first make the power budget analysis just to be sure that it's possible to do that.
Yeah.
And that's for now let's say, not the limit of the energy harvesting, but we need to find the right project that can integrate the energy harvesting first.
Yeah. And then what's the next step?
The next step of the implementation?
Yes.
Yeah, so the next step is just to help the customer to create the schematics.
Yeah.
This is the next step. Create the proof of concepts, just to let the customer feel that it's possible and that it's possible to make a fully autonomous device.
Yep.
And after, when it's done, production, and that's the main goal.
So in all the experience that you have at EPs and all the experience that you have with energy harvesting, if in our community they're considering energy harvesting,
yep.
What are your top 3 applications where you go, I know we can take batteries out of that?
Yeah. So first,
we like that one. We can do that one,
control.
and we understand that system.
Yeah.
What are the other? Give me 3 others.
So tracker, asset tracker. It's an application where we can remove the battery because there is some tracker for outdoor, there is tracker for indoor. So the energy is present and the power consumption it's quite small. So we can implement energy harvesting in those kind of systems.
So logistical tracking.
Yeah.
Where something's right. Okay.
Exactly. After there is application in the industry where you need to monitor the temperature, the humidity, or this kind of application that can be possible to implement.
Technology.
Yeah, exactly. Sensor application where you need to measure the CO2 in the atmosphere, for example.
Yeah. And is there a data limit at what point you can't support that? Is there a data limit? So obviously, if it's a sensor, it's sending its data somewhere or it's creating data. So where's the cutoff point in terms of the data that you can manage in terms of power?
So the measure the temperature, for example, it's not very complicated and the power consumption is not too high. The most consuming part is the communication at the end.
Yes.
Bluetooth communication that's consumed nothing, let's say. So it's easy to implement energy harvesting.
Right.
LoRa communication also. LoRa, it's possible to supply thanks to energy harvesting. If the frequency between 2 communication, it's every 1 minute, let's say, it will be possible. And after there is also LTE communication. This one is possible, but the frequency it's every 1 hour, for example. You send the data to the network.
So there are restrictions, but you've just described, 3 very commonly used communication protocols.
Exactly.
That you're very comfortable replacing battery technology with energy harvesting.
Yeah.
Very good. And so just from EP's point of view, do you have a solution for all of those, and do you have a different chips, or are they using a different chip and then you have to help them implement that?
So for the energy harvesting today, we have 15 different PMIC that can be implemented, depending on the voltage on the source, the voltage on the storage element, and so on. And depending on the feature that needs the customer on his design, we can propose the right PMIC and help the customer to select the right one.
Right. Okay. Well, I think you've given a very interesting to find out how alien technology, quite frankly, replaces the battery from that, how you build a system to make that completely, self-reliant regarding power, and then just a quick introduction as to how the design engineers, the parameters by which they can consider energy harvesting, the things they got to think about, why then they should come and talk to you.
Yeah.
Thank you very much.
Thank you.
Well, I am personally sick of changing batteries and remote controls, and I'm sure as a consumer that you are too. So let's thank EPs for a solution and get evaluating this technology on ipXchange.tech. Also, I know that we have design engineers at Microsoft in the community, so hint, hint.